Hi guys, this next lesson is about the Pythagorean Theorem and more specifically finding the length of a missing leg. In the last lesson you guys learned that the Pythagorean Theorem states that a squared plus b squared equals c squared, and that a and b are the legs of the triangle and c is the hypotenuse. So if we have a right triangle, as long as we have this 90-degree angle, we know automatically this is my A, this is my B, and the line that connects A and B is that C, the hypotenuse. So today what we're going to focus in on, what if I give you the hypotenuse and I give you a leg? How do we find that missing leg? So if we look at example 1 in your note packet, we have a right triangle and they're giving us that one of the legs is 3 and that the hypotenuse is 5. So what I always do is I start by just labeling all of my variables. So for A, I have no idea what A is. They didn't give me that. But B is 3 and C is 5. So I'm going to plug everything into my formula now. So remember, my formula is a squared plus b squared equals c squared. Okay, so a squared, I have no idea what that is, but I do know that my b is 3. I'm going to square it, and that my c is 5, and I'm going to square that. Now, a squared, I'm going to leave. I know that 3 squared is 9, and 5 squared is 25. Now, this is just a basic algebra problem. Draw your line. We're trying to get a squared by itself. So I'm going to start by subtracting 9 from both sides. And I end up with a squared equals 16. Now what you can think about next is, you can think about what number squared is 16. Well, I know that 4 squared is 16. So my answer is A equals 4. That's one way to look at it. Another way to look at it, which will help you in the future, especially when the A ends up being something different than a whole number, is I end up taking that A squared that's equal to 16, and what you can do is, to undo squaring, you square root both sides. So kind of like adding, the opposite of adding is subtracting. The opposite of squaring something is square rooting it. So I square rooted the left side, but then I got to square root the right side. And that cancels out the square root and the square. So now I end up with A equaling 4. So whatever way you want to look at it, but I would suggest you looking at this piece, because in the future, when the numbers don't come out as whole numbers, that method will help a little bit better. All right, next problem. I look at my triangle and I want to first identify all of my variables. So I know my A is 12, that's this guy. My B, I have no idea what that is. And I know my C is 13. So I'll get into my formula. A squared plus B squared equals C squared. I know my A squared is 12, so I'm going to do 12 squared plus B squared equals C squared, which is 13 squared. I know that 12 squared is 144. And I know my 13 squared is 169. Now, remember, your job is to try to get B by itself. So I'm going to draw my line, and I'm going to subtract 144 from both sides. And so B squared ends up being 25. For the next piece, you're thinking, what number squared is 25? So you should know that B would end up being 5, because 5 squared, 5 times 5 is 25. Now remember that other way I taught you is if we look at it a different way, where we have b squared equals 25. To get b alone, we're going to undo the square. And we're going to do that by square rooting the left side as well as the right side to balance. That square and square root cancel out, and we're left with b equaling 5. So in the end, we still get 5, but I like the second way better because it will help with those weird numbers that are going to pop up in the next couple problems. Next problem, number 3. They're giving me a side length of 17. So I'm going to call that B because they're not giving me my A. So I'm going to have A equals question mark, B is 17, and C is 24. So I'm going to plug it into my formula. A squared plus B squared equals C squared. A, I have no idea what that is, so I'm going to do A squared plus my B, which is 17 squared, and C, which is 24 squared. So I'm going to rewrite A squared plus 17 squared, which ends up being 289, and 24 squared, which is 576. Now these get kind of high, so if you forget, you got to do 24 times 24. You'll get 576. Now, your job is to get this A squared by itself. Draw your line. I'm going to subtract 289 from both sides. And what we end up with is A squared equals 287. Then to get the A by itself, remember thinking what number squared is 287? This one's a little harder to think about. So what I would do is use our second way of getting A by itself. So we're going to undo that square by square rooting the left side to cancel out, because you're undoing that, and then square rooting 287. So you're going to need your calculator. You're going to have to punch in the square root of 287, and you should get about 16.94. So because it's about, we're going to say A, and do these little squiggly lines, 16.94. And that is your answer. Number 4. This time they're not giving you the picture, they're just giving you a sentence. So it says find the missing leg length when one leg is 2.7 centimeters and the hypotenuse is 6.5. So if it helps, you could draw a triangle, and you know that one of the legs is 2.7, the hypotenuse is 6.5, and you're trying to find this guy, and we'll just call it A. You could call it A or B, doesn't matter. So we're going to label everything that we know. My A, question mark. B, 2.7. C, my hypotenuse is 6.5. So we're going to plug it into our formula. A squared plus B squared equals C squared. A is question mark, so A squared. B squared is 2.7. Remember to square it. And my C is 6.5 and square it. All right, so we're going to keep A squared. 2.7 squared. 2.7 times 2.7. 7.29. 6.5 squared. 6.5 times 6.5. 42.25. Now remember, you're trying to get the A squared by itself. So we're going to subtract 7.29 from both sides. Cancel out. And we're left with A squared equals 34.96. Now it doesn't matter that it's a decimal. We're still going to undo the square by square rooting it to cancel out. We're left with A. Then we got to square root the right side. So you're going to have to type in your calculator. Square root of 34.96. And you get A is about 5.91. And I'm going to make it more clear. We're going to make little squigglies instead of the equal sign because it's about 5.91 centimeters. And you are done. Last one. This time with your triangle, the only difference here is they are giving you the side length, which that's the same, but the hypotenuse is the square root of 104. It's still going to be set up the same way. So I'm going to write that my a is the question mark, even though it can be a or b. My b is the 2, and my c is the square root of 104. I'm going to leave it as square root of 104 for now because 104 is not a perfect square, and I don't want to write the whole long irrational number. So we're going to have a squared plus b squared equals c squared. My a, no idea what that is, but my b is 2, so I'm going to square it. My c squared, all right, follow this. We're going to do the square root of 104, because that's my c, and then I'm going to square it. Okay, so that's how it would look. Now, we're going to have a squared. My 2 squared is 4, we know that. Remember what I talked about with square roots and the squaring. These actually cancel out. Square roots and squaring something cancel out like what we did before. So you're just left with a plain old 104 now. Now, your job is to get the a squared by itself. So you're going to draw your line, subtract 4, and you'll end up with a squared equals 100, which is nice because you know that what number to the second is 100? A is 10. So that is your answer.